Good day, everyone. Today we shall be considering partial fraction. By the way, this is Gifted Brain, aka Saizu, first in Africa, sixth in the world. Let's consider this example 2 now. To solve this question, I just rewrite the question and then we go ahead. And to every linear factor, again, we assign a partial fraction of the form a over. I didn't consider rule 1 here because I know I was not going to divide. As you look at the denominator, if you expand the denominator, you have s raised to power 3. And since the numerator is lesser than the denominator, so I'm not going to divide. So I went ahead to rule number 2. So to every linear factor, I'm assigning my partial fractions now. S minus 1 and then plus c all over x plus 2. And so here we are now. So I am almost done with this question. The only problem here is my a, b, and c, and that's what we want to obtain now. So I by fraction, joining fractions to join the fraction of the numerator of these partial fractions now. So that way, the LCM of the partial fractions are s plus 1, as usual s minus 1, and then x plus 2. So that's all. So sorry, my lines. Okay, so that's about that. And then the next thing I will do now is to say x plus 1 goes to the denominator, will give me s minus 1, s plus 2 times a. S minus 1, s minus 1, s plus 2. And then plus s minus 1 goes to the denominator, will give me s plus 1, s plus 2 times b. So s plus 1, s plus 2 plus c into bracket. S plus 2 go through the denominator will give me s plus 1, s minus 1 times c. And so this is what we have now. So the next thing is to write the left hand side of the equation. Now, after having the left hand side, because the left hand side fraction and the right hand side fraction have the common denominators, we are going to eliminate it. So we eliminate the denominators, and so we have only the numerators left on the left hand side, so which is 4x squared plus 7x plus 1. So these things are not, shouldn't be equal to, should be equivalent, actually equivalent. So being equivalent to, although some people ignorantly write equal to, but appropriately should be equivalent till we get our value of a. So plus 2, then plus b into x plus 1, x plus 2, and then plus c into x plus 1, x minus 1. So right from here now, I could solve using any of those two methods I used the last time to solve this question. So we're looking at each method, which one we're going to consider each method in solving this question now from here. So what I will do here now for this method is to eliminate maybe a, b, or c. And the way to do it as usual is to take any term and equate it to 0. So any of the linear factors, and equate it to 0. So look at it now. I could take x minus 1, one of the linear factors we have, and equate it to 0. Obviously, I will have s being 1. So I will have x being 1. So x will be 1 here. So I will just simply say let x be 1. Let x be equal to 1. So if I do that, I will have 4x, sorry, not x now, because I've said let x be 1. So what I will have simply is, so this will just simply eliminate a and c, because from the a, 1 minus 1 will give me 0. So everything here should be 0, and everything here too should be 0. So at the end of the day, I'm simply left with sum the left hand side up. I will have 12, and then on the right side, I'm going to have b times 2 times 3, and that will give me 6b. So at the end of the day, we can say b is equal to 2. Again, is for us to say let x be equal to, before we do that, take another linear factor you can see there. Another one we have is s plus 2. So take that one and equate it to 0. At the end of the day, you realize that x is equal to minus 2. So just say let x be minus 2. Let x be equal to minus 2. And you substitute 2 into that same equation. And so at the end of the day, upon substituting minus 2, you see that here a will be eliminated because minus 2 plus 2 will give me 0. Multiplied by everything I have in the a will give me 0. So this a is gone. B likewise will go because minus 2 plus 2 will give me 0. So this is gone. At the end of the day, on the left hand side, I'll be left with 3. If you simplify, you have 3. And on the right hand side, if you simplify, you have minus 2 plus 1, which is minus 1, multiplying minus 3, which is 3 times c. So at the end of the day, we have 3c. And then we have that c is equal to 1 if you divide both sides by 3. So again, is to take another linear factor you can see there. We've used s minus 1. We've used s plus 2. Another one we can see is s minus 1. So just say x minus 1 equals 0. Equate that linear factor to 0. And then you realize that x actually is equal to 1. So you just simply say again, let x be equal to 1 and substitute it into the same equation again. Sorry, we've used s minus 1. Sorry, what we're supposed to use here is s plus 1. We've used s minus 1 before, so it's s plus 1 we are supposed to use. So we'll get x equal to minus 1. That's a mistake. S equals to minus 1. Minus 1. Thank you. So I will substitute s equal to minus 1. And then now we have what look like this. Okay, so upon substituting, we have this, and then we simplify. On the left hand side, we have minus 2. And on the right hand side, we see that b will be eliminated because minus 1 plus 1 gives 0 times b, and that's everything else. I'll get 0. And the same thing happens here. So at the end of the day, we will now have, on the a part, we have on the right hand side, we have minus 2a. And so we have that at the end of the day, that a actually will be equal to 1 on dividing both sides by minus 2. So we've got our a, b, and c. If we still choose to use the second method to get our a, b, and c, it's by comparison. I'll just do that second method shortly so that we can also get conversant with it, whichever method, so it doesn't look like you are seeing something different in partial fraction. No. So this is where we are, and we want to use the second method. 4x squared plus 7x plus 1, which is the method that will lead to simultaneous equation. A into x minus 1, x plus 2, and then plus b into x plus 1, x plus 2, and then plus c into x plus 1, x minus 1. So after getting this, all we just need to do is to expand each of the brackets first of all. So expanding each of the brackets. If I do that, I will have a into, if I expand these two brackets here, I will have x squared. Then carefully, I will just show the final answer, what it will be like. X squared minus x plus x, and then minus 2. This is what we have here. I'll do that for the b and then the c too. And then I will simply expand each of the brackets. If we expand each of the brackets, we have if we expand each of the brackets, we have a x squared plus ax minus 2a, and then you do that for others too. So I will compare coefficient now. The first thing I will do is to take maximum power of x, which is x squared. Whatever I have x squared, bring out their terms. So on the left hand side, I will have 4. While on the right hand side, I will have a, which have s, and b, and then c. So if we solve this simultaneous equation, we will get a being 1. I've compared the x, I've compared the constants. So a being 1, we get b being 2, b being 2, and we get c being 1 as well. So we are done. Actually, I'm just trying to show this number 2. All you just need to go back to that fraction you first wrote and then substitute the value of a, b, and c. I mean this fraction we have here, and then I will just put the value of a, b, and c. So we just substitute the value of a, b, and c. A as 1, b as 2, and c as 1 again. So at the end of the day, our final answer will look somewhat like this. This is our final answer. I also realized that while solving this, I say let x be equal to minus 1, but I didn't effect it here, so please take note. It's minus 1, not 1. Minus 1, not 1. Okay, so that's that about that. Let's take another example. So this example 3. The first thing to do here is to ask yourself, subject it to rule 1. Do I need to divide or not? Now to look at it now, the degree of numerator is 3, while the degree of denominator is 2. Since that of numerator is greater, even if it's equal, likewise you also divide, but here it is greater, so you need to divide. So we divide this polynomial. If you don't know how to divide polynomial, you need to go to our video and watch polynomial on how to divide polynomial. So but I will do that briefly here. So this is how we just divide a polynomial. I write the numerator inside and then write the denominator outside, as I've done here. And so the next thing I will do is to say, taking the first thing here, which is x squared, allow the x squared to divide the x cube. Only the first term with the first term here. X squared goes in x cube will give me x. And I will use this x I've gotten, this quotient x, to multiply everything at the denominator, which is what is here. So x times x squared will give me x cubed. S times x will give me x squared, and then s times minus 2 will give me minus 2x. So this is what I will have. And then the next thing I will do is to subtract. I will subtract what I have here with the what is above here. So if I subtract, I will have minus 6x being left, because x cubed minus x cubed will give me 0. X squared minus x squared will give me 0. 4x minus 2x will give me 6x. So this is what is left. So I can write this question as being x cubed plus x squared plus 4x all over x squared plus x minus 2 being equal to sorry, this is not minus 6x, sorry, this is plus 6. Okay, so being equal to, you write first of all your coefficient, the answer you got while you divided, which is x, plus your remainder, which is 6x, then all over your denominator, which is x squared plus x minus 2. So this is what we have. And now it is this one, what we have here, we separate by partial fraction, because it is the fraction. This x is a whole. You can't separate this x into by a partial fraction. No, it is this x you separate into its partial fraction. That's that about that. And now I want to say again, I stopped dividing because maybe this is your first time of doing this problem. I stopped dividing because x squared can no longer go in 6x, because the power of x squared has a higher power than 6x. That's why I stopped dividing. This is where you're dividing, we stop, and then you have this answer. Now let's separate 6x over x squared plus s minus 2 into its partial fraction. So the first thing you will do as you take the 6s over x squared plus s minus 2 is to try factorizing it. If you factorize the denominator, you will have s plus 2 and x minus 1, and then so that you can have linear factors. That's why you factorize. So at the end of the day, you now say a over x plus 2 to each linear factor, and then plus b over x minus 1. And then we can go ahead to do what? Join the two fractions, which will be x plus 2 as their LCM, x minus 1. And then x plus 2 goes to the denominator, will give me a into a multiplied by x minus 1. And then plus x minus 1 goes to the denominator, will give me b multiplying x plus 2. And I will write the left hand side likewise. So we've written the left hand side, and you see that they have common denominator, so we eliminate the common denominators. So at the end of the day, we'll be left with 6x being equal to a into x minus 1 plus b into x plus 2. And then we can use any of the method. Here, I will use method 1, and you can try any other method. I prefer the method 1 actually. And so all I just need to do is to try to eliminate a. To eliminate a, take any of the linear factor. Take the linear factor in front of a and equate it to 0. So x minus 1 being equated to 0. So I'll get x being 1. So I will simply say let x be equal to 1. Let x be equal to 1. If we do that, we have, so a will be eliminated actually, and then we have 6 being equal to 3b. At the end of the day, my b will be equal to 2 if I divide both sides by 3, sorry. Again, is to say take the linear factor in front of b to eliminate b. Take it and equate it to 0. If I do that, I will have that x should be equal to minus 2, and I substitute that again. I believe from here you know what to do. So we'll get our a, if you carefully do it, to be 4 at the end of the day. So since we're getting our a and b, just substitute it into the partial fraction. That means putting your values of a and b here. Substitute the value of a and b here. So our final answer will become, in our final answer, remember you divided at first. So it will be x, what is here? I will come to this equation here. I'll write x, then what I got by separating this partial fraction. So my answer will be somewhat like, and so this is our final answer. So you can attempt the following question shown to you now, and the answers are also written, so you can solve and then compare what you have with the answers. So you can attempt the following questions, and by the time you attempt these following questions, you will have acquainted yourself with rule 1 and rule 2. In our next video, we'll be taking rule number 3 and then rule number 4. So just attempt this and then check on our next video, so you can have a complete knowledge of partial fraction. At the end of all these videos, you should be able to, any day, anytime, solve any question on any partial fraction. So thank you, and God bless you.